Hello dear friends, welcome back to my YouTube channel Chemistry Aspirant. Now in today's lecture we are going to learn about tricks to identify the type of hybridization of an atom in a molecule. So now let us start how to find out the type of hybridization of an atom. So before to know about the type of hybridization, we must know a few basic terms. So let us discuss about these basic terms first. We know that when a molecule is formed, there is always a central atom. We must able to predict that central atom in that molecule. So to predict this central atom in the molecule, we have a few criteria. Now which are that criteria? First criteria is that usually the central atom in the molecule have a least subscript number. Now let us consider the example regarding this one. Here I have taken the methane molecule. The molecular formula is CH4. So the carbon do not have any subscript, while the subscript of the hydrogen atom is of 4. So here the carbon is central atom in methane molecule. Let's consider the second criteria. Central atom usually form the most number of a bond in molecule. Here I have taken the example of PCl5 molecule, that is your phosphorus pentachloride molecule. Here the phosphorus form a 5 bond with the chlorine atom, hence phosphorus will be the central atom. So that is our second criteria. Let us consider the third criteria. Usually the central atom have a least electron negativity. So here I have taken the example of IF7 molecule. We know that here the electronegativity of iodine have a lower value than the electronegativity of the fluorine, that I have shown here. So here iodine will be the central atom. Now let us consider the fourth criteria. Usually the central atom is found least in number in a molecule. Now here I have taken the example of H2O molecule, that is water molecule. So here if you observe, in water molecule there is only one oxygen atom and two hydrogen atom, hence oxygen will be the central atom. So these are the four different criteria by which you can easily identify central atom in the molecule. So now let us consider the second term, that is nothing but the valence electron. You know that the total number of electron which is present in the outermost atomic orbitals are known as a valence electron. So here I have given a chart in which I have shown the different elements and the total number of a valence electron in this element. Now this chart will be useful to predict the type of hybridization of a central atom in the molecule. So I request you to take a screenshot of it. So now let us consider the next term, that is nothing but the lone pair of electrons. We know that the valence electrons that are not shared by the atoms in the bond formation is nothing but the lone pair of electrons. Generally, for identifying the type of hybridization of this central atom in this molecule, we will predict the total number of lone pair of electrons on the atom on the basis of total number of valence electron which is present in that atom. Now let us consider the example. Here you know that I have taken the example of water molecule. Oxygen is the central atom. So here the total number of valence electron in the oxygen atom, just refer that chart again, is equals to 6. So here we know that after observing this oxygen molecule, the two hydrogen atom attached to the oxygen atom, here the 2 electrons out of these 6 valence electron, the 2 electrons are used by the 2 hydrogen atom. Here the 4 electron will remain as it is. If the total valence electrons are 4, so they will remain as a lone pair. So obviously we know that in the lone pair there is always a 2 electron, hence the total lone pair will be equals to 2 as the total valence electron equals to 4. So on the oxygen atom there will be the 2 lone pair of electrons. So this is the basic thing you must know before predicting the type of hybridization of the central atom. So now let us consider one simple trick to find out the type of hybridization of a central atom. We know that on the basis of these few basic terms, generally the type of hybridization is considered total number of atoms which is attached to the central atom. So just we have to find out the total number of atom attached to the central atom plus the total number of a lone pair of electron present on the central atom. So by adding these two numbers, we will obtain the total number of atoms in the molecules, which gives the type of hybridization. So here I have shown one chart. Now in this chart, if adding the total number of atoms and the total number of lone pair of electrons, if that number comes to be 2, the hybridization will be sp. If the number comes equals to be 3, then that hybridization will be sp2. If the number is equals to 4, then hybridization will be sp3. If the number is equals to 5, the hybridization will be sp3d. If the number is equals to 6, the hybridization will be equals to sp3d2. And if the number is equals to 7, the hybridization will be sp3d3. Again I request you to take the screenshot of this table. Let us consider the example. Here I have taken a simple example of a methane molecule. We know that in the methane molecule, carbon is the central atom. So to predict the type of hybridization in this methane molecule, we will find out the total number of atom attached to the central carbon atom. So here in the methane molecule, the total 4 hydrogen atoms are attached. Hence the total number of atom attached to the central atom is equals to 4. Again, we know that the valency of the carbon atom is equals to 4. So here the total number of hydrogen atom attached is equals to 4 and the valency is also 4. So here the total number of lone pair of electron will be equals to 0, as the 4 electron is attached with the 4 hydrogen atom in the methane molecule. So here if we find out the total number of atom in this molecule is equals to the total number of atom attached to the central atom, that will be equals to 4, and the total number of lone pair of electron will be equals to 0. Hence the total number of atom in the molecule is equals to 4, and if the total number of atoms in the molecule is equals to 4, then the type of hybridization will be sp3. Let us consider the second example, that is ammonia molecule. So here again you know that the central atom in the ammonia molecule is the nitrogen atom. So here you can observe that in the ammonia molecule, the 3 hydrogen atom is attached to the central nitrogen atom. Therefore the total number of atoms attached to the central nitrogen atom is equals to 3. The total number of valence electron in the nitrogen atom equals to 5. So out of these 5 electron, the 3 electron is used to form bond with the 3 hydrogen atom. Here the 2 valence electron will remain as it is and they will act as a lone pair of electron. So here the total number of atoms in the molecule is equals to the total number of atom attached to the central atom. For the ammonia molecule it is the 3, its value will be the 3. Again we know that the total number of lone pair of electron on the nitrogen atom, as there will be the 2 valence electron, hence it will be the 1 lone pair, therefore it will be equals to 1. Therefore 3 plus 1 will be equals to 4, and hence the number of atom in the molecule is equals to 4. The type of hybridization will be the sp3. In this video we have taken only few examples. Now in the next lecture we will know about how to predict the type of hybridization in the different molecules.